Let's figure it out from Wittgen. The titles until death do our part, comparing longitudinal outcomes possibly ending death. So us.
Yeah, thank you very much. I'm extremely happy that there's a debate following because my point of view is very different from what you just heard. If the data and the question don't match, it's not the data that are wrong, but perhaps the real world is what you want to know something about. So your question wants to pertain to that. But so to give a flavor, we had the choir trial before, and Sunday before jumping on Eurostar, we were actually rehearsing this piece called Immortal Bach, and it's sort of relevant, I think, and it starts with just a few bars of real-world Bach, and then the composer continues post-Bach with a piece that has no baroque harmony at all, no rhythms anymore at all. But so it's a hypothetical Bach that follows from that, and that we have sung. I'm sure nobody would recognize Bach in it. And the other thing about this I like, and is a bit of relevance here, is how one thinks about death. Comme Zeus of thoughts, comme zeer geroe. So there in the song, it's a release, it's something they long for, and clearly death has its own meaning to different people. I think it's also peace for those in Gaza, but not everybody wants it. So for me, death is highly, highly relevant in the outcome of treatment. It has a very distinct meaning from quality of life, and that meaning may differ for different people, and that should be recognized if at all possible. And so I have not been thinking about this alone. So there was a renewed interest because of this IMI CISAPOL European project that started about 4 years ago, and Stratos, Striking Analytical Thinking in Observational Studies, partnered with CISAPOL to help develop guidance on the design, analysis, and reporting of clinical trials with patient-reported outcomes and quality of life. And it's not, and it's really recognized that in oncology, where all this takes place, survival is an important outcome, but also more and more quality of life. You don't want to stretch life at all costs necessarily. And so in the Lancet Oncology of December this year, these guidelines were published, and many other things happened, and publications showed up. So there are 2 work packages in this European project, one on the randomized trials and one on single arm. And single arm is where Stratos with the observational studies primarily was active, but also in the randomized trials. So Saskia Lessassi led that one. And we worked with a bunch of PhD students on this particular team. You don't have to also be better. So to try and be a bit grounded, as the previous speaker, this is one example that one of the partners contributed from Pfizer. It was a single-arm trial. There's also a randomized trial of the same treatment that we will look at later as well. In advanced lung cancer, that is not rare, and it's a hard endpoint, I was always told. It's the least fuzzy of all endpoints that you usually get. There's a lot of it in the study. There were repeated PRO, patient-reported outcomes, measured over the 3-weekly cycles of the chemo, really. A cold score between 0 and 100 was analyzed and measured here. And there were intercurrent events from start to finish, progression of disease, treatment discontinuation, and death, if you call it that. And this picture here gives you an idea of how over the cycle, so this is 63 weekly cycles in all, there were calls, quality of life measures taken, and you see how that number goes down and it also alternates a bit. On the one hand, the red color are the deaths that have occurred. So that also, the volume of that increases rapidly. More than 50% of the patients have died by then. And then intermittently or in between, you have call not available and on and off treatment, and call available and on and off treatment. That were the data. considered very important. This drug, I'll come back to it. So if there hadn't been any deaths, it would have really been having to just measure across the time points the average quality of life in the new treatments and in the control that will also come, and then compare that and consider that, possibly baseline stratified, of course. So here is sort of the start of follow-up, which is at a particular diagnostic moment, and then the treatment starts, randomized versus control, or just a single arm treated, and then the call measures 3 weekly under disease progression, treatment discontinuation, and possibly death. So here we will take a treatment policy approach in the sense that these intermediate intercurrent events we ignore. We just want to know time to death and the quality of life experience until then, or until our last follow-up measure. So we can ignore these intermediate ones, but death we must do something about in the analysis. There's no way to ignore it. And already in the way people describe the data in abstracts of papers that are not unimportant, there are lots of different wordings. And I thought I would like to know how you guys think about this. So, so one of the wordings has been that I consider death an inconvenient truth. It's there, it's inconvenient for us statisticians, but we should handle it. Now also for the patients. There is at least one paper in abstract that talks about our outcomes may be incomplete due to death. And my question is, what would you call incomplete outcomes in a setting like this? The outcomes that you get from the patients who are observed to die during follow-up, the outcomes of the patients who are censored during follow-up, both or neither. What are incomplete data in this setting? So who would say that the patients who show their quality of life until death and their death, that is the incomplete data that you get from them? Hands up, please. Who would say that the patients who are censored before they die on the study, who would say that they give you incomplete data? Yes, thank you. Who would say both? You. Who would say neither? Nobody.
Can you tell us what your estimate is? Because some people
Yes, so I agree. So that's why the previous slide said we would like to have the mean quality of life assessed. If nobody died, that's
not the formal estimate.
Excuse me?
That's not the formal estimate.
Well, that's what we would want if everybody stayed alive. But here, yeah, that the two questions hang together, of course. What would you want to estimate
before we
so I will tell you in a minute what I think is the most interesting one here. But bottom line is it's a consequence of treatment for the patient in terms of the combination death and quality of life. Both are key ingredients of what they can expect following this treatment. A survival time and I would say while alive, a quality of life.
Is that an estimate?
Well, it's data. And then we will look at the expected value of the data over time. Okay, so which do you call complete then?
I need an estimate before I can say it.
Okay, we'll come back to that. So some people say we call quality of life censored after death. That's what I read in many descriptions here. And what does that mean? Quality of life is censored after death. There are well-defined and unobserved quality of life measures after death. And assumptions must be made about the missing data mechanism to understand the real data distribution. Is that what it means to be censored? That there is something there, but we can't see it? Or is it co-measures post T are not well defined? Or is it they do not exist? Restricted outcome space for this joint two-dimensional outcome time of death, and quality of life over time. So we would, if censoring is a word that's used, how would you interpret that? Who would interpret it as A? One person. Who would interpret it as B? Few people. As C? Also a few people. Okay, so the bulk of the people are again not answering, but these sort of statements, and in particular the previous one there, was the first. This thing about incomplete data due to death is the first sentence in a summary or abstract of an invited session that comes up at ICB. Post sentences after death and truncated by death. What does that mean, truncated by death? They are well defined with unobserved co-measures post T deleted from the analysis set. There are investigated defined but never observed co-measures post T deleted from the analysis set, or is it something else? What does it mean, truncated by death?
Just means it doesn't exist.
Yes, it doesn't exist. So your analysis set changes over time when it comes to that particular variable because it only exists for a subset of people. So what I am in favor of, with me, a lot of people in the cis-alcohol group, is to acknowledge that we really have, at every time point that we consider, a two-dimensional outcome. One component of it is an indicator of, are you still alive? And the other one is, if you are, your quality of life at that moment. If you like to have a mathematical, no, that's it. Nothing else. There's nothing. There's no quality of life after death. Unless you imagine or invent something, but there's no data on it ever. So unless you imagine or invent it, it's the end of the road. And so with the two-dimensional potential outcome or observed outcomes following one particular treatment, you can look at the expected value of the one, expected value of the indicator of being alive, it's your survival chance at that time, and the expected value of the other, for whom it exists, and that is only for those who are alive. And you may consider that two-dimensional outcome at every time point under the two potential treatments, AS1 and AS0, say. For me, that is something that really matters. It's what we have data on. We should consider it, and we should compare it between treatments. But again, we get papers to write about RCT comparison are biased if they look at the data that exists. That is bias. If specific values substituted for death, you have a composite strategy. So that happens. Sometimes people think of death as the worst possible quality of life, fill in a 0 for it. If you imagine that or find that, then there is something post-death. But if you do that, are you then biasing the comparison between the two arms? If automatically you fill in a 0 value for quality of life after death. Is that what's biasing things in the comparison? Or second, and what is predominantly done is the hypothetical strategy, and mixed models are used, so random effects with missing at random, implicitly imputed. If you do that and compare groups like that, hypothetical strategy, are you then biasing the comparison?
What do you mean by bias?
Yeah, that's the question, yeah.
Isn't that with respect to entity?
Excuse me?
A bias is defined with respect to entity.
Well, yes, but clearly those who write that think that at least one of these is biased. Although in each case, there's a clear estimate, and if you compare that estimate between the two treatment groups correctly, it isn't biased for that estimate. But some estimates, some people think, is biased by design, and in fact, it's this one. It's not if you fill in 0 after death. That's fine, that's your estimate, let's compare that. Not if you assume that missing at random continues post-death for your quality of life. So you plug in values, and the point there is it's extremely important to appreciate how close to death you have had measurements of quality of life. Because right before death, the quality of life goes down dramatically. And so what you want to extend there in a missing at random fashion, what is going to keep happening depends extremely on how closely you have measured and how you prolong or extrapolate quality of life beyond death. And here you have the two-dimensional outcome that I just defined. And if you call that one biased, then really you are blaming nature that kills people for biasing. In the other case, it's the investigator that chooses how to define things after death. But here, nobody chooses it. It's really, in my view, the true consequence of the one treatment or the other, that you die at a particular moment. And not embracing that in the outcome of these oncology patients, that seems a bit strange. Calling it bias, if you could intervene on it somehow to make it a censoring of, I would rather call these bias and not death. So these are the places, so some places where I read this. So in Carlin, who did a lot of great work in this field, she calls it censored by death. And Chechen says it's undefined, it's truncated by death, and he says inference about the effects of a point treatment or exposure restricted to individuals who are alive at follow-up visits could be biased. And here this data due to death are incomplete. That's the invited session at the next ICB session that starts with that summary. So what's in the name? I think there's a lot in the name because, of course, it can only be censored by death if you assume there's something ongoing, and then that something ongoing you must somehow invent because there is nothing real for real. The true data nature has nothing to offer there, impossibly, and it's non-positivity to the extreme. So just to give an example, and I have to watch the clock here, of what has been done, but I don't want to dwell on it too long. So this single arm trial has been compared with control arm of randomized trial in the same drug. And of course, one wants to start it with exchangeable populations to the extent possible. The colors here have a risk profile of the people. It sort of sets equal at the start. And then as time progresses, death at time t1, so the survivors at time t2, so that group gets depleted by death at differential rates. So we need the mixture of risk factors over time in the living population that starts from here will change. In addition, there will also be likely a dropout due to censoring that may also depend on these risk factors. And as here suggested by these shaded bricks. So those are people that are still alive, but you don't see them anymore. They have been censored by them. And here I'm just sort of having density functions of the risk factor distribution among the living over time. Yes, that's no longer the same risk factor composition, but they all start from the same. So the average treatment effect in terms of the two-dimensional population that starts here in the exchangeable fashion is the contrast between the survival chances for these people over time, and given that they are alive, who amongst this is alive and shows you quality of life that are these subsets of the living. So here you see in this analysis of the single arm trial versus an RTT control arm, completely similar design, but inclusion criteria were stricter for the randomized trial, they were healthier. So what you see here is that a sensible comparison between the single arm trial, average quality of life among the living over time, and you see the drug takes a little while, but then it really acts well. And the control arm, the crude data on the control arm, the raw data show you this story. But if you standardize it to match the baseline risk factor distribution of the single arm trial, then you pull that down a bit, and that is the observed ATG contrast amongst the living there of their immune quality of life. So for this particular drug, it turned out, and here we're showing you 3 survival curves of the single arm trial, and the baseline provided matched 2 arms of the randomized trial, and really the survival curves are identical, I say. And here you see that difference in expected quality of life amongst the living as time evolves. And in this case, it's good news. This is from a simulation study, but I won't dwell on that. The second case study I have is in glioblastoma trials of brain tumors. Again, I won't dwell, but this is a standard randomized trial, and again, there are lots of deaths in this group. At week 46, 59% alive in one group and 67 in the other. That is considered unusual progress in survival for this group. Almost no treatments exist that prolong their survival, but this one does. And then the question was, yeah, okay, their survival not better, but is their quality of life maintained? And this is just the observed distribution of the measured quality of life over time amongst the living. And you see that it's pretty much maintained with the improved survival. Yeah, that's the survival improvement curves there. Okay, so the question is, in situations like this, can you draw or infer meaningful action from the results if we look at this 2-dimensional outcome estimate? So we could think of different scenarios. If both survival and quality of life are better under the experimental treatment, if one is equivalent and the other is better, or if one is worse and the other is better. All 3 scenarios are possible, are real, and will matter to the people who have to choose which treatment to take. One could argue that in the first 2 scenarios, it's clear what is better. If on the experimental treatment, your survival is either the same or better, and or your quality of life while alive is the same or better, well, I would think the choice is easily made which way you will want to go. And to estimate these, you need relatively little cross-world assumptions, which is assumptions about something you really don't have data on unless you have a causal model imposed on the real world. That may be violated, may or may not be true, and cannot be really tested on the whole. So that sort of decision that might come from this sort of evidence could be made at population level for policy purposes. If you are health insurance or FDA or EMA, who are part of the IMI CISACO, I think you would know what to do for the population benefit and justify the cost. Also at the stratified personal level, I think I would know what to choose. And if it was not a one-directional answer, I would want to know and still make my own choice. I wouldn't want anyone else to make it for me. And you cannot talk this away. It's a reality. Both components are, we think, an important reality, even though up to them, people usually only mostly consider survival time. Now here I have a hypothetical scenario that might be behind these population average data over time. So suppose you have a treatment which in fact on the individual quality of life, or it could be any other measure, cognitive functioning, blood pressure, has no impact. But what it does, when it kills people, when people die, so the experimental treatment targets more unidentified frail people. So that in the end, the survivors under the experimental treatment show up with a better mean quality of life than in the other group, but the survival curves are identical. So at the population level, that is what you see. At the individual level, at some sort of detailed personal level, things go on that are not visible that if you knew exactly who got what, of course you could choose individually, but on the whole, that's not the case. And it's also an unlikely scenario. In fact, I had also brought up here, so there's a lot of resistance against apparently the two-dimensional outcome of data that are real-world data. So the implication of call after death is by far the most prevalent way of handling that. And there is a survival after causal effect that works on a cross-world defined subpopulation, not identifiable. Is it an actionable target for intervention? It's a big question. And I have to say the way the assumptions are posted to make this happen, this estimate, so the monotonicity assumption that the effect of exposure on survival agrees in its direction across individuals. So the scenario, the weird scenario that I just depicted cannot happen, is assumed to be impossible to go there. And the non-parametric identification is achieved by leveraging post-exposure longitudinal correlates of survival and outcome that may also mediate exposure effects on survival and outcome. But supposing that the longitudinal data arise from a certain non-parametric structural equations model. That's what the abstract says of this paper. And then there is somewhere in the paper that is what you need to be able to have this estimable survival average causal effects. So when I first explained the first heavily contested two-dimensional outcome, there was a community there of joint models people who said, this is the answer to this problem. That is how you should handle it. So we have worked on it and we have looked at what might that give us for questions that we think are interesting and relevant. So a joint model for quality of life for the repeated measures at these discrete time points and survival would be your repeated outcome at time tj for person I is a baseline covariates linear effects plus some other covariates that have random effects, person-specific effects. We just looked at initially a random intercept and slope plus some noise, and a hazard that may also depend on its own baseline or exogenous, in our case, time varying covariates, plus the same random effect, so that frailty of the person is allowed to affect both the survival hazard and the quality of life. And so you have to make some assumptions. So the assumptions that are typically made is fully conditional independence. So given these person-specific random effects, that Y and the survival data are independent, and that the repeated measures of Y, their correlation is also handled through that steady random effects, person-specific evolution that you see there. Here's a picture of that simulated picture. So here you see a bunch of straight line realizations from that model with a single person that you follow there with the population mean call or after resurrection. So it involves the full U distribution. And then here the mean call while alive is the blue line amongst those still alive that start from there with that random effects, and here is the survival chances over time. So it's work to fit it, and the expected value of Y given the baseline covariance and the survival up to T is calculated by involving the random effects U out of that multivariate model that is presupposed, and then you look at the chance of Y and T over the S of T. So this is how it's done, and what we have simulated this also once under a version of the model that was already published. And here you see how over a limited number of time points in that simulated model, you have in blue the mean Y amongst survivors, in black the immortal mean, if everybody stays in your data sets, and observed here are those light blue dots. So remember, the dark blue dots here are the mean quality of life amongst the living, and the black is amongst the original full population to begin with, the immortal sample, if you like. Okay, and so if you just look at the beta from the linear model parts, where you end up with that parameter is in the immortal group story. But if you do what I just showed you, you average over the use of the survivors, then you come back to. And the little interesting thing for us was that so the pink line here is based on GEE modeling with independence correlation matrix, inversion weighted for sensory. It let us in fact do it better than plugging in the estimated use, random specific random effects estimates, even though the data were here generated under that joint model with those random effects. So the model is perfectly fitting, but if you do it right, you do recover more or less that those means, those true means, but the mean effect estimate time point does it better. Of course, once you have person-specific effects and models, you can start modeling the personal story as we saw it in this. As you saw it with every individual evolution line and over time, and that is good. That's an added advantage under the modeling assumptions, of course. What we have used it for as well is to try and predict poor outcome in intensive care unit. They want to do that because they don't want to have very aggressive therapy for the people who will either die soon or come out with really horrible quality of life anyway. So with that joint model, we can predict that. The only trouble there is that, you know, these joint models and these random effects models also mixed. They have a shrinkage story. So the really bad results are not seen if you estimate these things via blobs because of the shrinkage. But in the JASA relatively recent paper, McCulloch and Nohas developed a method for mixed models to overcome that, and we have extended it for these joint models so that you do get much better estimation in the tails of the subject-specific starting points and evolution, and you can flag much better from early data up to the landmark what will happen next. So what I haven't spoken about here, I only spoke really about non-existing whys due to death, but of course in settings like this there are also missing data, and in particular with disease progression and treatment discontinuation, the rendering of ongoing data has become difficult. So post-treatment discontinuation, there are lots of missing quality of life data. Very big question if it's missing not at random, non-positivity too. So you could move and say, okay, if we have no data post-treatment discontinuation, maybe we should work with comparisons while on treatment. But that is, of course, a whole other story. We don't do that. So while on treatment is very, very different than while alive. This is a human intervention. While alive is not. While alive is really the outcome that matters. So in conclusion, I would say real world outcomes matter to the bitter end. And if it's bitter or not, that's up to those who experience it. But that's the full story. That's the consequence. That's what happens. And we see like young women wanting to know if my child will go to school, will I still be alive? And will I have the cognitive function to help it? It's a highly relevant combined question for many people in all kinds of settings. It's, in my mind, a well understood and valid outcome. It's average treatment effect on the starting population for the two-dimensional outcome. That is really the one that matters to many people. It can inform policy and also personal policy on treatment choice, it needs relatively few cross-word assumptions to establish, less than most other methods. It is useful. I think it deserves more attention. It's almost never looked at. Mind gap in language, I would say, because I agree. Your estimate determines whether anything is censored or truncated or not. And simple is also beautiful, I think. I just have one more slide. Thank you for your input so far in the debate. I really thank the organizers. I think it's a fantastic forum to discuss things that matter in practice on positive influence. Okay.
Can you go up back one slide? This is very complicated. I think to say that you need relatively few crossword terms, when you don't need anyone at all. So that's when you consider it the vanilla element in the product. It's just the you don't need it. It's just the obvious thing to report to the product. So nobody disagrees now that this is a different estimate of interest. The question is that people often know.
Well, there's a bit of crossword in the single arm trial, and you bring in external data, but
it's not the crossword estimate.
No, it is not. But as soon as you do a what if question, if you interpret it that way, it's a bit across the world. So the what if, but the origin of it is not. You are right. Yeah. Yeah.
Yeah, thank you. You had one slide where you mentioned very briefly that we need to characterize who survives. And that's important. And I also interpret when you talk a lot about personal decision making. I want to know when I still be alive when my child goes to school, and then I want to. We need a better characterization of the people who will survive under one or the other treatment, because they might be very different, and depending on that, that might select out people with better or worse cognitive function. So how much information we have, because we need very detailed data then. And I think
I agree with you, but I think that's also true when you're just comparing two survival curves. So you have to typically make the treatment decision at the start. And so what you have at the start, a whole bunch of baseline covariates, maybe genetic information. So all of that can be adjusted for in the usual way, and then it's specific to that point. What appears to be more
mean adjusted by conditional, that
conditioning, strategy,
whether it's different or not. So you know whether there are different people who survive until a certain point in time.
Yes. So for the covariate vector at baseline, you can estimate this two-dimensional estimate over time for each value of it in the usual.
Could you do that in your applications?
Yes. I haven't mentioned this covariate baseline covariate, but it is adjusted for it.
It is then really important to have to say the same people survive or not under different treatments, or
yes. Because in fact, the way these marginalized estimates have been constructed is by first doing it covariate specific and then standardizing over that.
But you lose that if you report, if you say, so we, as in your application, the proportion of survivors is roughly the same, then we have lost the information whether it is the same people. If the proportion could be the same.
Yes, but if you compare that between men and women, older and younger, and you go, so in each stratum like that, you have the two things observed, survival and quality of life. So this estimate could be calculated specifically for any baseline covariate vector. And in fact, in the final analysis, we have done it for that plus a subject-specific random effects. But also there, it was additionally adjusted for covariates. And there, after a few weeks or a few cycles, we go back and estimate the person-specific you had, given the data that they've shown so far.
So you're okay with doing person-specific effects?
Excuse me?
You're okay with doing person-specific effects in mixed model?
Yeah, it depends a lot on the random distribution that you assume there. So
okay, so you think that's easier to justify than some of these other estimates?
I don't think it's necessarily that more difficult to justify in a way.
Causal interpretation. How would you write that then?
But so, yeah, the models for each of the treatment it's the same way, but they are use specific.
Do you have an expression?
Excuse me?
Do you have an expression for it?
If you, yeah.
On the factual station, or is it, I don't know, like.
So this is in every arm, you know, so
for
that,
every unit.
yeah, or this could be the treatment effects,
So
the
it's the
treatment.
same treatment for every unit beta, for each I, yes.
So this goes across the different groups and the axis.
But should I interpret as every individual has exactly the same weight beta?
Every individual has the same beta.
So how widely then?
Yeah, no, you're right. So we are not.
That's the same effect.
Yeah, this is.
Why you look at man and woman?
Yeah, no. So in here we have men, women based on characteristics.
But they
Plus-
have the same beta.
Yes.
So
So-
everybody has the same effect.
If you like.
Well, that's your model. I mean.
Yeah, but you can go further there. You could
You're
push it,
inside
but
other models for being straight. Here you're saying that everybody has the same effect.
yeah, the average effect on that scale, but they have
It's
also
not
this
the average, it's
interacting.
each I
Yeah.
and J.
Excuse me?
It's not the average, it's for each I and J.
Sorry.
I don't know if it's an average, but it's for each I and each J. It's the same beta.
Yes, but this hazard acts on the new, so the survivors, things change, the surviving subpopulation is changing along the way, That's what this is, reflecting here. But you're right, so it doesn't, at that first level, in this case, it does not, assume individual level differential effects, but you could, right? But you would have to make even more joint use assumptions of the distribution. It's not impossible, but through this mechanism here is a differential impact of survival given the use. So in the end, it generates, and that's the whole point. It generates the same. Oh no, where am I? It generates the same GEE means as we had before, by averaging over the U. But you're entirely right. Thinking that you can recognize the different U's in a very exact fashion depends on the distribution and model. I would not be inclined to do that, because then it becomes, if you depending on your interpretation, cross world at that level.